the calculator problems. Here we go. Calculator problems say create a box like usual. I'm even too lazy to write it down. But you know what we're doing, cutting the corners out. This is kind of review. But this problem shows up all the time in all kinds of calculus books and whatever. The book or the paper is 10 by 12. And the volume must be at least 80. So we want to find the size of the cutouts. Okay, we are on problem number 5. We're doing the calculator problems on the same sheet, page 6, that we were doing before. All right, so what is going to be my expression for the volume? 10 minus 2x, 12 minus 2x, and x. And that has to be greater than or equal to 80. Okay? Now, if we want to, there are a couple different ways we can do this. But if we want to, oops, turn it on first. Now, let's talk about domain like we did before. What are my x values? What's the smallest x? 0. X can't be negative, so the smallest x min is 0. What's x max? 5. So we're going from 0 to 5. Now, I'm graphing volume. Isn't volume going to be a positive quantity? So I'm going to put y min as 0. Y max, I have no idea, but I know it has to be at least 80. So let me just start with 100. Right? We'll see what happens. And then I'm going to type in my equation. Now, I'm going to actually type in 2 equations. I'm going to type in this side right here like I have before. And then I'm going to type a separate equation that's 80. All right, so I'm going to put in 2 equations. So 10 minus 2x, 12 minus 2x, and x is one equation. And then 80 is the other equation, just 80. I'm going to press graph. All right, what happened?
Oh, yeah, you just find the answer.
What do you see? Do you see your parabola like usual, right? And then you see a line going through it. Now, you want the volume to be at least 80. Now, at these points right here, would you agree it's 80?
Yes.
It is more than 80 here, right? So our answer is this point to this point. Would you agree with that? So now I need to find those points. So second calc, what do I go down to if this is the way I've done the problem? Intersect.
Did you change your,
I left my window exactly the way we said it was going to be. So this point worked out to be, 1. And then the other one is 2.76. So those are my 2 points of intersection, and everything between them is more than 80. Now, in this problem, I mean, it happened the way I set things up, that I saw the top of the hill. Would it be absolutely essential in this problem for me to see the top of the hill? No, because what's the top of the hill? The maximum volume? And was that what this question was after?
no.
No. So if it wasn't, but if it had been cut off, it really wouldn't matter, because these are the 2 points that I need to see. And since I'm more than that, that would be the whole thing would be my answer. All right, if you have calculator issues, you need to get in here. You just need to get in here to sort it out. All right, number 6, another review problem. Some 12% juice Amount times percent plus amount times percent equals amount times percent. Here we go. Some 12% juice and some 18% juice are mixed to get 50 gallons of 14% juice. I heard somebody out there say, we've already done these. Yes, we have. Enjoy it. Enjoy knowing what you're doing. Now, I've got my percentages filled in, and I've got the one and only amount they gave me. The only amount they gave me was 50. How much 18% juice did I mix in there? So I'm going to let this be X, because that's the 18% juice number, or that's where 18 is. And it's how much of that, so that'll just be my X. What will this be then? Oh, perfect. 50 minus X. If the whole thing is 50, and this much of it's X, then this has to be the leftover part. 50 minus X. All right, now we can use a calculator to help us if we need help. Multiplying. So we end up, let's see, what is that? Watch this subtraction, that's 0.06x. About 16.67 gallons. Yeah. All right, anybody have a question about that setup? Now, number 7. We have not discussed, you and I, so it's good. We'll do this one. We'll pull one off on the review sheets too. But you know how for these mixture problems, I have kind of a format that I'm suggesting you use because it's simple to remember and it always works. All right, read problem number 7. You've done these before. They're classic first-year algebra problems. Okay, Rachel takes 3 hours to do it. If Emma helps, it only takes an hour. How long does it take for Emma to do it alone? The format that will work every time, and you may have your own method from first year algebra, and that's fine, but a strategy that will always work is 1 over alone plus 1 over alone equals 1 over together. So when I say alone, I mean their time alone. So you normally have 2 people. This will work with 3 people. It doesn't matter how many people you have. 1 over the first guy's time alone plus 1 over the second guy's time alone will be 1 over their time together. So in this problem, Rachel takes 3 hours, so we're going to start with 1 over 3. If Emma helps, it takes 1 hour, so this would be 1 over 1, because that's their together time is 1. How long for Emma alone? So 1 over Rachel's time, 1 over Emma's time, which is unknown, adds up to 1 over their time together. How do you suggest we solve an equation that looks like that? You could subtract 1/3. You don't have to, but it would be easy to do that, right? 1 minus 1/3. And then cross multiply. So how long does it take Emma alone? An hour and a half. 3/2 hours. Now, if you just go to the next page, we'll do one like it. You just go to the next page, which is page 7. We'll just do another one since that's the first one you've done. Look at problem number 8. Problem number 8 is an identical type of problem. Okay? So 1 over alone plus 1 over alone equals 1 over together every time. So John can do it in 3 hours. So 1 over 3. If Mary helps him, they can get it done in 2 hours. So 1 over 2. how long does it take Mary alone? Does that setup look okay? These are pretty simple. Now, over here was a little easier. If you want to go ahead and subtract this over, you can. It'll work fine. The strategy that we have been doing is to multiply by the common denominator. I don't care if you do that or not. That's how I'm going to do it. Because if you subtract 1/3, aren't you going to have to get a common denominator anyway? So it's fine. If that's what you want to do, it'll work every time. It's not a problem. I'm going to multiply. So I have 2x plus 6 equals 3x. So x equals 6 hours. It takes him or her 6 hours to do it. All right, so even though we've never done one of those, do you have a grip on that, do you think? That was off the review sheet. All right, now we're ready for number 8. Back on our paper, we're going to try to get this done. All right, we want to minimize the size of paper. So we're going to find a minimum to accommodate 120 square inches of print with the indicated margin. So you're creating some kind of poster or something, and you have to have 2 inches of margin here and 3 inches here, and I guess 1.2 inches here and 1.5 inches here. So whatever you're making, those are the margins that you've set up. And here in the middle, you have to have 120 square inches of space. All right? And we want to minimize the size of the paper. So that means the area, right? We want to minimize the area of the paper. Now, we know that the paper would be 4.5 plus something. Would you agree with that? Because we got 3 inches over here and 1.5 inches over here. We just don't know how much this is. Would you agree with me? And we know that this dimension is what? 2 plus 1.2 plus something. This, whatever this is. So I have no idea what the length and the width of this inside box are. So what if I just called this X? This piece right here, I'm calling that X. What would this piece have to be? Well, I don't want to use 2 variables because I've already got a variable here and I'm going to put it in my calculator. I'm going to find a minimum now, so I'm going to minimize. So I need an equation to put in my calculator. I can't call it X. What? I mean, it might work out to be X, but do I know that's a square in there? Did they tell me it's a square? So I can't call it X. I'm going to call it 120 over X. Why?
To get the area of that, you do length times width.
Exactly. You need the area to be 120. That's length times width. So if the width is X, then the length has to be 120 divided by X. Because what happens when you multiply these two things together? You get 120, which is what has to happen. So the paper all the way across is the 3 and the 1.5 and the X. So one dimension of the paper is 4.5 plus X. This dimension is 2 and 1.2, and this, which is 120 over X. So that's 3.2 plus 120 over X. There is your area of that paper. Again, you know you have 2 and 1.2, and this is 120 over X. So all of that added up gives you your length. You know you have 3 and 1.5 and X. All that added up gives you your width. Now, I'm going to type that in on my calculator and look for a minimum. My window is set, but I'm gonna leave my window alone. Let's see what happens. I don't know what's gonna happen. Let's type in this equation. Don't FOIL it out, you don't need to. You can leave it just like it is. Gotta get rid of the 80. I'm not seeing anything. How about you? Okay, so that tells me a couple of things. First of all, I'm going to make my X's a little bigger, and I'm going to make my Y's a little bigger, and see if I can see anything now. Okay, well, I thought I saw something. Now you want to see a low point. So as soon as you've got some kind of shape that you can identify a low point, you're good to go. So I'm looking at something that looks like this a little bit. That's what mine looks like. And my window is 0, 40, and 0, 700. That's what I finally settled on. Those aren't the only dimensions you could use, but that's what I use.
0, 40, and 0, 700.
And that's what I use. And I just did that trial and error. There are lots of other numbers you could be using. Now, I need the minimum, so I'm going to look for a point right down in here, right? So I'm going to do second calc, minimum. And I'm going to set my cursor like up here somewhere and out here somewhere, because I want to find the low point in there. Mine's a little bit jagged, so I'm making sure I have the low point. I'm setting my window or my bounds nice and big. And I got 12.99 comma 217.54 basically. Now, what did the question ask for? This is always what I have to do. Minimize the size of the paper. Okay, now what that means is, what are the dimensions of the paper? This by this, right? When you got this number, you got two things. You got X,
So why is your area?
and this is the actual area of the paper. So what is, it says minimize the size of the paper, so I'm going to give the dimensions. The dimensions are going to be 12.99 plus 4.5, that's going to be the width, that's this one. Oh shoot, is that 17.49? I typed it in wrong, but I think I can do that in my head, is that right? And then the other one is about 12.43 or 44.
What's that X-ray? Oh, that's top.
So the size of the paper is 17.49 by 12.44. If the question had said, what is the minimum area? Then the answer would be 217. If it said, what is x, the answer would be 12.9. If it said, what are the dimensions of the printed space, it would be 12.99, and whatever 120 divided by 12.99 is. So there are all kinds of questions that could be asked, but you would be doing the same work for all of them. Okay? Let's see quickly if there's another one like that. Yeah, look on page 8. Look on page 8. The very last problem on page 8. It says the math department, very last problem on page 8. The math department wants to minimize the amount of poster board needed for the next math lesson. The department is committed to having 144 square inches surrounded by borders of 1.4 inches on the left, 2 inches on the top, 1.75 inches on the bottom and the right. What is the minimum area? So that's the question this time. What is the minimum area? Okay, how do you find area? Length times width. So here we go. What do I know about my width right off the bat? I know my width is going to include what? 1.4 and 1.75 and whatever this is. So let's call that x. So my width will be x plus 3.15. Did I add right? Is that right?
Yeah.
Okay. Now what about my length? Well, my length is going to be 2 and 1.75, and this. Now, if the total area of this inside box is 144, if this is x, what's this? 144 over x. So your length is 3.75 plus 144 over x, 2 and 1.75 for the boundaries, and then 144 over x for the paper itself. All right, I'm going to leave my window the same and just see what happens. Type this in. Remember, all you're looking for is a low point. So whatever it looks like, oh, that window works fine for this problem too. I get something that looks an awful lot like this when I put it in. Are you seeing? I didn't change a thing in my window, and I got something that looks like this again.
Is that usual for these problems?
For what? The shape is usual, yes. The shape is usual. And if you look at that, Brenton, it looks kind of like a reciprocal function. You know, it has that kind of shape. Remember, you kind of have a reciprocal function built in. So it's common that that's the shape you're going to get. Now, that window may or may not work, but that's the shape that you get a lot. All right, so second calc, minimum. Set those boundaries so that you're on either side of what appears to be the low point. And my low point this time is about, I'm going to say 11, because when I round that off, it becomes 11, and then 238.3. Is that what you got?
Our like calculus are getting like a
opposite of that.
Is this what everyone else is getting?
Oh, yeah, mine's
It goes
exact.
up.
So I know.
That's not good.
No, that's not good. Okay, so the answer to the question is, what is the minimum area? So the answer would be 238.3 square inches would be the minimum area. This is the minimum point. This is your X value. That tells you how big that paper has to be, or how big the print has to be. And this gives you the area of the paper. Okay? Now, let's quickly get the last problem done, and then I'll look at your calculators. Back to sheet 6. There's one problem left. This was off of the review sheet. One problem left says solve. Back on 6, which is where we were. We have one problem left, so I'll get that done. So we have x squared plus 3 over x equals -4. And you are to solve this, and it's a calculator problem. So here is what I am going to do. And you might agree or disagree, and that's up to you. But I am going to go ahead and clear the fraction, multiply everything by x. And then I'm going to get it set equal to 0. And I am not going to use the quadratic formula. You can't. It's not quadratic. Now, some of you did on your test. You had an equation like this and you used the quadratic formula. Just because it looks like a quadratic doesn't mean it is when it's got a 3 hanging in there. So they're saying use your calculator. So I'm going to put a standard window. I'm going to go back to a standard window because I'm solving a regular equation. I'm going to type in this equation, x to the 3rd. How many answers might I get? I might get 3. Now, I don't have to get 3. I might only get 1, and indeed I do. If you use a standard window and graph this equation, do you see 1 time it crossing the x-axis? So second calc, 0. This time we're choosing the 0 option because we're solving an equation, not looking for a minimum, not looking for an intersection. We're solving the equation, and I got x equals -0.674 if I round it off. Is that what you got? Okay, now you turned in your homework. You have 2 review sheets to be working on. So be working on those 2 review sheets in the packet. And those of you who need help with your calculator, bring it up. Those of you